At this point in time, we're going to move on to our final speaker today, Danil Zburivsky, Director of Big Data and Data Science at Pythian.
Thanks, Steven. Hi, everyone, and thanks for joining us today for this discussion. So what I would like to do for my part of the presentation here is to talk a little bit about the evolution of the data warehouse and how we moved from reporting in a single source to reporting in the cloud, and what challenges and assumptions we have to make when kind of following this progression. So here at Pythian, we help businesses and companies to manage disruptive technologies like cloud, like machine learning and analytics. And we have a wide range of experiences with different types of analytical platforms, both on-premise and in the cloud, which allows me to draw some parallels and kind of see how technology evolved from along the time, and what changes do we see when it comes to the managing and working with the data in the cloud. So if you look at the sort of simplified timeline of what a typical BI reporting at a small or medium-sized company might look like, that it wouldn't be surprising for you to see that the first generation or very primitive BI platform is just reporting on source. People go to their operational database, and it doesn't have to be MySQL, but there can be any other relational database, but they just run the reports directly on their operational database until they realize that, first of all, they are overloading it with unnecessary queries, and second, there is no tracking of history. There is no way to tell what happened and how certain data changed. So this usually pushes people to adopt a proper data warehouse model, and they might buy something from Oracle, or they might put a SQL Server warehouse at this point in time. And what happens is this infrastructure starts growing around this warehouse. The whole infrastructure of components start growing, like ETL tools and data ingestion tools and reporting tools. And at some point, it's becoming harder and harder to manage this type of environment. What we have seen over the last several years is that the unsatisfaction with a single kind of big box type of warehouse systems led companies and businesses to move to more distributed engines like Hadoop to replace the existing systems. And so not only scale and performance, it's also the ability of Hadoop to ingest any types of data and be able to delay processing to the point in time where you actually want to do something with the data. So you can store data fast, you can process it later, you can scale the system out, and overall, it looked like a good solution to the most painful problems in the BI world. But what we're seeing now is that there are more and more reasons for people to consider cloud as their data platforms, and we here at Pythian do a number of migrations of infrastructures from on-premise to the cloud, and a lot of them are driven by BI and analytics. So a lot of the migrations that we see are specifically driven by the need to move analytics in the cloud. So why cloud is so appealing for analytical use cases? And I know Kevin mentioned a few items already in his presentation, but really what's from our perspective makes cloud so appealing are a few things. First of all, it's time to value. You're no longer required to provision or buy big hardware boxes and deploy them on-premise. You can get instances set up in minutes, and that significantly improves the way and increases the speed at which you can get to the results. Scale and elasticity is definitely a big benefit of the cloud. You can use as many resources or as little resources as you require for any particular job, and you can adjust those resources dynamically. And related to that is cost. If you're not using a lot of resources, when your ETL may be only running for a few hours a day, if you're in a batch mode, which still a lot of the businesses are, then you can save dramatically on the cost of the system by just not running it when you don't need it. And the last point, I think, is a really important one to consider, because there's a whole new generation of the data warehousing products out there provided by cloud providers themselves. Like there's Redshift from Amazon, there's Google BigQuery, there's Azure Cloud Data Warehouse, there are third-party products like Snowflake, And I think it's really important for people to focus on what are the key features of those new generation data warehousing products, because we believe that they will be driving a lot of the demand for the cloud migrations. So what we see here at Pythian is that if you want to move your existing BI platform into the cloud, or you're planning to build a new platform into the cloud, just relying on existing and old architectures is probably will not be good enough. Like, it doesn't make sense to move your one big box warehouse into the cloud. Interestingly enough, our experience shows that in many cases, it doesn't even make sense to migrate your existing Hadoop cluster into the cloud as is if you already have one, because there are better alternatives that exist in the cloud, like Elastic Hadoop clusters available on demand, or specific services like Google Dataflow that are completely managed. And that eliminates the need for having a large Hadoop cluster running all the time. So there's definitely a need to rethink the way the architecture in the cloud for analytical platform would look like. And the way we approach this problem here at Pythian is we think that the warehouse in the cloud will be replaced by a multi-component platform where warehouse will be just one of the components. Like, it's no longer going to be a center of the universe, which is doing all the ETL, all the complex computation, all the transformation. It's not going to be the place where you land data before it gets consumed. It will become a serving layer for you to be able to connect your BI tools, and it will only present like this cleaned up and curated view of the data that is more interesting to the BI analyst and business for their reporting needs. Which means there must be some other components in between the data and the warehouse, which would allow you to collect, process, store, and manage the data set. And the way we approach this problem here at Pythian is we introduce this kind of layered architecture for the analytical platforms in the cloud. And the key layers are obviously the flexible ingestion layer. There's cloud storage, which all of the three main cloud providers like Google, Amazon, and Azure provide. So it's an object store that provides a very cost-efficient and scalable way to store large amounts of data. And there are a number of execution engines to do your ETL, and we'll talk a little bit more about this in the future slides. And finally, there is a warehouse component, which will take the cleaned and prepared data for you and allow you a SQL access using your BI tools, or allow connecting your internal external applications to the system. So we're trying to replace one monolithic BI system with a multi-component solution. And the reason for that is we strongly believe that BI, as it is at the moment, is significantly lagging in maturity from, let's say, software development processes, where there's a whole industry around continuous integration and testing and provisioning that makes productivity, which provides significant productivity boost to developers. All of those tools are lacking in the modern BI world. And we believe that there is a better architecture that can allow us to achieve the same level of velocity you would expect from a highly skilled software development team to get your BI platform running. So if we look at each of the individual components, I just spent a few minutes on giving some of the options that we see can be used for data, let's say data ingestion in the cloud. I mean, there are numerous options. There's obviously some custom scripts you can write. There are a number of third-party tools and services, and Kevin talked quite a bit about their service for data integration, Unity, which is definitely an option you can use to get your data into the cloud. There are some cloud-native options. There are connectors that both Google and Amazon and Azure provide for their warehouses. But our strong belief here is that there's also a overlooked set of open source tools that can provide a significant increase in the speed to which you can get data ingestion. And here at Pythian, we worked quite a bit with a product called Apache NiFi. It's an open source tool that allows us to do this small portion of just the bigger warehouse, like analytical platform needs, is doing the data ingestion. So obviously, when the data is ingested into the cloud platform, there's a number of steps that you need to do. So sometimes you need to do some light ETL, but in many cases you have to do some significant transformations on your data. Examples are being building a customer 360 view or providing a whole history of customer purchases in a view that's acceptable to the business, which means you need a scalable, you need a scalable engine to do the large-scale transformation. And again, our belief here at Pythian is that SQL, being a great data access language, is actually not a good language for ETL for the reasons I mentioned before. It's really hard to test. It doesn't have any good developer ecosystem support. So our recommendation and the way we deploy platforms to our customers is we're using Apache Spark as the alternative to the complex ETL. You can run it on a number of elastically available cloud services like Datafrog on Google, EMR on Amazon, or HD Insights on Azure, and it comes with the support for batch and streaming, which means by moving from a kind of SQL style language to a proper procedural language like or framework like Spark using Python or Scala or Java, you can significantly improve the life cycle of your development, and that will allow you to achieve your results faster and get the data curated and prepared for consumptions. So finally, the last bit of the architecture for the BI platforms in the cloud is some kind of SQL warehouse where you can connect your BI tools to. And we think that the right solution at this point in time is to pay attention to what Google is doing with BigQuery, what Amazon is doing with Redshift, or what Microsoft is doing with the Azure Cloud Data Warehouse, because there's some interesting innovation there, and they also introduced new models for consumption. There's pay-per-usage type of models where you can scale the cluster for a certain workload. For example, maybe a heavy report needs to run, and then you can scale it down and not pay for the rest of the processing power. Google takes it even one step further with their BigQuery, where you don't even have to worry about scaling the service. It comes as a fully managed solution where you just need to get data tables defined, load data into them, and Google will scale everything on your backend for you so you can run queries at any size. So we believe that this component is one of the most critical pieces, and using this cloud-native solutions where companies like where cloud providers put enormous amount of investment in innovation is the right way to address the problem of how would the BI architecture in the cloud look like. So really some conclusions here is that I think everyone agrees that the cloud unlocks new opportunities for analytics. We also see that all BI architectures, they don't work properly just ported as is into the cloud, including even the more recent Hadoop deployments. We also think that warehouse will become just one of the components in a bigger cloud analytical platforms where each layer will do its specific task, but it will do this task way better than the solution that tries to do all of them at the same time. And finally, in the cloud, it's really important to pay attention, close attention from the day one when you start thinking about migrating your BI to analytics to things like how are you going to monitor your solution? What about security and automation? In the cloud, automation is the key. You can't afford, while you don't have to rack up your servers or wait for the hardware to be provisioned, you need to be able to use the power of the cloud through automation. If you don't have the strong layer of automation in your system, then probably you will be spending a significant amount of time just trying to manage all these different layers together. And once data is becoming distributed and it lives in different parts of the system, like there's ingestion layer, there's processing layer, there's a warehouse, the need for the data governance is definitely increasing. And the need to have a good set of business processes around who can access data, who can see which parts of the data and which data can be shared with which part of the organization or third party is really important, because technology, when it comes to data governance, technology can only solve part of the problem. A big part of the problem is actually having a good set of business processes that will make your organization ready for the cloud. And with that, I'd like to thank everyone for joining me today. If you would like to continue the conversation on BI in the cloud, there's contact information on this slide. Feel free to get in touch with me.
Danil, our next question is for you. How would you compare performance of an on-premise and a cloud-based data warehouse?
Yeah, that's a really good question. The short answer is it's actually pretty challenging to compare those two systems because it's like comparing apples to oranges in some sense. I think what's really important to consider here is that while you can have a very fine-tuned on-premise data warehouse, which provides spectacular performance numbers, it's really hard to beat the ability of like Google or Amazon to scale the clusters almost infinitely to the workloads that they want to adapt. So you may get better performance for one types of queries for the well-tuned data warehouse that you run in your data center, but for let's say 90 percentile of the queries that you run, the ability to get the resources they need in time is probably more important than the sub-millisecond response for certain scenarios. And analytical use cases usually don't demand that level of latency anyway. So I think the answer to that is it depends on your workload, but really what you'd be looking at is, can your warehouse system provision resources that your analytical tools and application need in time and not like a week after it was requested because you had to do some tuning or add indices and things like that. So that is the key consideration here.